Okay, April 19th, looking at the last couple of topics we've looked at in Algebra 1B, which is the standard deviation as well as the normal curve. And we're going to start with the standard deviation. And let's say that we just took a quiz and we're going to look at how some of these scores compare with each other. So in our class, we took a quiz. There was a score of 80%, 75%, 77%, 81%, and 79%. In order to calculate the standard deviation, first thing we're going to need to do is calculate the mean. So use your calculator, find the mean of these 5 numbers. And the mean is something we should be pretty good at this point. Add all those numbers together, divide by 5. And I got a mean of 78.4. All right, so that's the first step. We're going to find the mean. So let's say this is my period 2 class. I picked 5 results. The average of those 5 people, 78.4. Okay, that's fine. Now, we're going to calculate this standard deviation. And what is the point of doing standard deviation? So we can see on average, how consistent was the class? Were we all over the place or were we kind of clumped close together? Step 1 is to find the mean. We did that. Step 2, we find what's called the variance. So it's this little sigma squared. For this, it's going to be a big numerator. We take each one of these 5 terms. So the first one is 80. Subtract the mean, and then we square it. I could do 80 minus 78.4, or I could do 78.4 minus 80. It doesn't matter. But I'm going to do that with each one of these terms. I did it with the 80. Now I'll do it with the 75. 77. 81. And then lastly, the 79. So we have a huge numerator. This is going to be the most things you put into your calculator. And it's all going to be over 5, just like we did with the mean. When we're finding this variance, we put over the number of terms. So this is what I'm going to be putting into my calculator. Put my whole numerator, put everything in there. I'll hit enter. Then I have to divide that by 5. And I get my variance. Which is 4.64. The variance isn't really that important, only because it's a step along the way. Do I write it down? What we want, the significant number, is the standard deviation. So once you've done all of that, to get from this variance to the standard deviation, we need to take the square root of that. So I'll go back to my calculator, second square root. I can type in the number 4.64, or I can do the square root of answer, just a little bit less for me to type. And the standard deviation is 2.15. So if this is 5 people from one of my Algebra 1B classes, I found their mean, I found their standard deviation. On average, these scores are different from the mean by about 2.15. That's kind of a small standard deviation for this big of a number. So these are kind of closely clumped together. Let's say that I pick these 5 students, and in the same class, I pick another 5 students. Or maybe I go to another class and randomly pick 5 students for that one. So let's say in this other group, the numbers that from the 5 people, I get a 60, 70, 72, a 91, and an 82. So maybe these 5 people studied together. They got this average and standard deviation. Did they all score kind of close to each other by working together? Maybe. And then maybe I put these 5 together. They studied. We are going to eventually find their standard deviation, like how closely were they linked with each other. Step 1, though, can you find the mean? Always have to find the mean first. So can you find the mean for these 5 numbers? All right, I got their mean to come out to 75. Add them all together, divide by 5, we get the same thing, 75. So we add them all together. And then whatever that result is, we divide by 5, that'll give you your mean. So this gives us a good chance to talk about 3 measures of central tendency: mean, median, and mode. If there's no outliers, the mean is a good way to calculate our best measure of central tendency, just like the true average. If there's an outlier, then we might want to look to the median to see like a better measure, because that outlier can really skew the numbers a lot. But these numbers are close enough. There's no crazy ones in there. So the mean is a good one to look at. If I compare it to the other group, the mean of the first group was 78.4. So their mean was a little bit better than this one. Okay, those students did a little bit better. But we're really interested in the standard deviation. So step number 2, we're going to look for the variance again. Look what we did for the variance before. Can you calculate this variance? And this is the long step. A lot to put into the calculator. I'll give you a chance to edit all that in there. So here I'm putting everything in there. I can do the mean minus the number, or all the numbers minus the mean, squared, everything added together. So this whole numerator comes out to 564. There are 5 terms again, so we're going to divide by 5. Again, what would that look like? It would be 60 minus 75 squared, 70 minus 75 squared, 72 minus 75 squared, 91 minus 75 squared, and 82 minus 75 squared. And again, it could be 75 minus 60 or 60 minus 75. It doesn't matter. I'll either get a negative 15 or a positive 15, but when it gets squared, it gives us the same results. The variance is 112.8, which, when I compare it to the last one, is very different, right? The variance the last time was only 4.64. This variance is huge. The variance is one more step to our answer. Now we're going to take the square root of that answer, square root of 112.8, and we get 10.62. So the standard deviation for this one is 10.62. What do these numbers represent? Well, in group 1, here was the data we were given. Those were all the test scores. Here is the average. They averaged a 78.4, but our standard deviation was 2.15. Again, on average, each of these scores is different from the mean by about 2.15. Whereas in the second group, if you look at these numbers, they seem a lot more spread out. The smallest number is 60, way smaller than that one. The biggest number is 91, bigger than any of those. So they're already spread out a lot more. We get this average, which is pretty close to that average. So their averages are pretty comparable. However, this standard deviation number, this 10.62, I know it's kind of hard to see, this 10.62 is a lot higher than that one because, as I can see, these numbers are spread out more. On average, these numbers are different from the mean by about 10.62. The standard deviation tells us how closely bunched the numbers are. So there is our calculation of standard deviation. Know how to use our calculators to evaluate those. Instead of calculating, I want you to interpret what's going on here. Two groups. There's group A, there's group B. And let's say, again, we're just looking at test scores. Just keep it very simple that way. In group A, the average of their scores was a 72. Their standard deviation is a 3.1. Group B, let's say that their average is an 84. Their standard deviation is an 8. How do we interpret these test results? I'm going to ask a couple questions. Which group did better? Group A or Group B? Group B. How do we know Group B did better? They have a higher average, right? They got the better scores. Second question, which group had all of their results that were spread out more? B. I didn't give you all the numbers, but because this standard deviation is high, that means, yes, you had a good average overall, but your numbers were a lot more spread out. On average, your scores were 8 off of the mean, whereas these are more closely clumped together. These people were more consistent with their test scores, whereas these people were more spread out. That's how we interpret those kind of values. Go mean, standard deviation. Now, the numbers that I gave you, these are not normal. If I put these onto a graph, they would not make a nice normal curve. They'd be spread out a little bit, maybe skewed to the left, skewed to the right, and a little bit jagged. However, when we have a normal curve, if it's a true normal curve, I know how these numbers are going to be spread out. And this is what we looked at yesterday in class. If it's a normal curve, right in the middle is our mean. And if it's a normal curve, the mean is also the median. It would also be considered the mode. If it is a true normal curve, this middle is always going to be the perfect average. If we calculate the standard deviation, either one up or one down, there's a certain percent of all of the results that are going to be within one standard deviation. That number was 68%, which means in each one of these little regions, which are equal to each other, we're going to take 68 divided by 2, and each one of those is going to have 34% of all of the test scores in there. So let's say there were 100 people who took this test, and the results worked a perfect normal curve. 68% of the people, 68 of the people would be within one standard deviation, pretty close to that mean or that average. If you went out a little bit further to 2 standard deviations, then you're at 95% of the people. If I take 95 minus 68, that's 27%. 27 to split between those two. So if we take 27 divided by 2, we get 13.5% in each one of those. And these numbers are always going to be 34, 34, 13.5 and 13.5. If I go yet again, one more standard deviation. So this is getting into like more elite or more just like really low. This is 99.7% of the people. Almost 100%, almost there. If I take 99.7 minus 95, that's 4.7. 4.7 to split between this yellow region and this other yellow region. So 4.7 divided by 2 is 2.35%. Not many people were scoring in those extremes. And if I went all the way to the left, all the way to the right, 100 minus 99.7 is 0.3. So as we go even further to the left, it's 0.15% there, 0.15% over there. These are the number breakdowns for our normal curve. They're always going to be the breakdowns for the normal curve. These are the numbers you're going to need to know. Let me give you an example of this. All right, let's say that, we'll just go for a test again. Let's say there is a test. There's a big standardized test. A bunch of people took it, and it worked out that the normal curve worked. Like it is a perfect bell curve. The average, the mean, was 82%, and the standard deviation was 6. We're going to ask a few questions about this in a second, but before we ask questions, we're going to draw what this curve looks like, because drawing the curve is going to be the key to answering these questions about how well groups did overall. We're going to put our number in the middle. There's our mean of 82. What percent of these people scored above an 82? Do you know? Of all the people who took this standardized test, what percent of the people scored above an 82? 50%. Like all these people, 50% scored above an 82. What percent of the people scored below an 82? All these people, 50%. Okay, so there's our start. And then the standard deviation, it was calculated. We didn't calculate it. It was given to us, but it could be calculated. It was calculated. It told us that the standard deviation was 6. So I'll go up 6, go down 6, and I'm going to put the percentages in there. 34%, 34%. So question, what percent of the people scored between a 76 and an 82? Between a 76 and an 82, 34%. So again, of all the thousands of people who took this test, 34% of the people scored between a 76 and an 82. That's what this is telling me so far. We're going to go further. One more standard deviation to the right and to the left. So add 6, subtract 6. Get familiar with these numbers. Some numbers you just know. These are numbers you're going to need to know. What goes into these two big blanks? 13.5s. 13.5%, 13.5%. So at this point, I could ask a question such as, what percent of all the people who took this test scored between a 76 and a 94? The question, what percent of all these people scored between a 76 and a 94? What do we do to find that out? Add those up. 34 plus 34 plus 13.5. 81.5% of the people scored between a 76 and a 94. Let's take it further. Dot, 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 dot. Add 6, subtract 6. These numbers get smaller. What goes into these two little blanks? 2.35? 0.35. So 100%. Now maybe there is some extra credit that somebody can get on this one because we're going to add 6 one more time. Actually, we're not even going to put that number on there. I'm sorry. Once we get to this one, then like above that, it's the very small 0.15%, 0.15% forever to the left and forever to the right. Question. What percent of the people scored below 76%? So we have enough information with our drawing to answer this one. You might want to use your calculator. What percent of the people scored below a 76%? Use your calculator, use your numbers, use that chart. I'm sorry, below a 70, like it's below a score of 76 maybe. I didn't put a percent right here, so maybe they were a different number than 100 points. What percent of people score below a 76? We add up. Below the 76, add up all those numbers. Does that come out to 16? Yeah. So 16% of the people scored below a 76. Question. What percent of the people scored above a 70? Can you use that graph? What percent of the people scored above 70? I can add all of these green numbers together, or maybe a little shorter. What does all of this blue add up to so far to the right of the blue? We know that's got to be 50, right? Because that's like from the halfway point to the right. So this is 50 plus this. So maybe I can go a little quicker that way. Or I could take 100 minus these two numbers. It might be another quick way to make it happen. But are we looking at 97.5%, I believe? So of all the people who took this test, 97.5% scored above a 70. I'm going to add one more part to this one. We were told the mean was 82. We put that on there. The standard deviation was 6, so we added and subtracted 6 as we went to the side. And let's say that there were a total of 3,000 people who took the test. So one more piece of information. These are 3 things that we're told. And now I want to know how many people scored between an 82 and a 94. Not what percent, but how many people scored between an 82 and a 94. Here's my 82. There's my 94. So I'm looking at this region. I have these percentages. 34 plus 13.5, I believe, is 47.5. That's 47.5%. But that's not what I'm looking for here. My question is, how many people scored this? If I said how many people did that and you said 47.5%, that's not answering the question. How many people? Well, if there were this many people who took the test and I want to know 47.5% of them, can we figure out that number? 47.5% as a decimal would look like 0.475. So here's my 47.5% of, or times 3,000. And I'm getting 1,425 people then. I'm just figuring out then what is 47.5% of that number. That number is 1,425. So I can even answer this question more specifically, not just a general percentage, but how many people there were there. I didn't use this until the very end. I found the percent. I multiplied the percent by that. If I said 50% of the people, we take 50% of that. We've got 20% of the people, I take 20% of that. Percents to decimals, move the decimal point left 2, and that's what we multiply by the number. Let's look at your homework packet. I want to help you get started on one, and then you'll have some time to work on some of those other ones. So this should be homework 07. It might say 08 at the top, change it to 07. This one is due for tomorrow. First 5 questions deal with the percentages that we put in here. And I'm going to use this graph that was provided for me to put some of these numbers in here. Here is the dotted line right down the middle. That is the halfway mark. Because it's a normal curve, it is the median. It's also the mean specifically. Dotted line, dotted line. Let's fill in these percentages. What are the percentages that go into these 2 blocks? 34s, 34%, 34%. In a normal curve, 68% of the data is closely clumped within just one standard deviation. What are the next numbers? What go into those 2 regions? 13.5s. Now we're getting a little bit smaller. What are the percentages in these? 2.35, 2.35, and then on the outside, it's 0.15 and 0.15. We're going to fill in some numbers across the bottom for this one in this question number 6. But for these first 5, question number 1, what percent of the values in a normal distribution fall below the mean? Here's our mean. What percent is below that? 50. Number 2, what percent is above the mean? 50. What percent is within one standard deviation of the mean? So standard deviation to the left, standard deviation to the right. What percent is this? That's 68. What percent is within 1, 2 standard deviations of the mean? So what percent is inside of this pink? What do we get? You can add the left and then double it. You can add all of them together. 95. 3 standard deviations of the mean. So we're going from, from here to here. Almost all of it. We don't have 0.15 on the right. We don't have 0.15 on the left. If we add those, we get 0.3. So we're 0.3 away from 100, 99.7. And these are all percents. All right, question 6. 2,000 freshmen at State University took a biology test. The scores were distributed normally with a mean of 70. So it is a normal curve. This applies then. The mean is 70, so that goes right in the middle. A lot of times for your college level test, the score, the mean might be kind of low. A lot of science and math classes, the mean might be even like a 50%, like really, really smart people, and the score is a 50% mean. That happens sometimes, and they know the test was hard, so they put it onto a normal curve to make sure the grades look okay. The standard deviation is 5, so up by 5, up by 5, up by 5, down 5, down 5, down 5. So I've got all my numbers on here. Label the mean and the 3 standard deviations from the mean. We did that. There's our graph. Question A. What percentage of scores are between 65 and 75? Between 65 and 75. What percent of scores are we talking about? 68. Next one. What percent of scores are between 60 and 70? Add those together, 47.5. Try the next one. What percent of scores are between 60 and 85? Answer it on your own first. Is it 97.35? Add up those percentages. Okay, next question. What percentage of scores is less than a 55? 55 to the left, that is the very small 0.15%. Not many people score below a 55. What percentage of scores is greater than an 80? 80. Bigger than that. Add those together. Not many people, only 2.5% scored above an 80. Must have been a very hard test. Letter F. Now, for the first time, it's not asking for a percent. It's saying how many students scored between a 60 and a 70. Good news is we already did this question. Between a 60 and a 70 was 47.5%. 45.7% of what number, though? How many total students took the test? 2,000. We haven't used that yet, but we're going to use that now. So we want to know what is 47.5% of the 2,000 students. On my calculator, I have to change that into a decimal, 0.475 times 2,000. $950, so 950 students. It's not a percent. There are 950 students then who scored between a 60 and a 70. Can you figure out letter G? You have a little bit more to do on this one. How many students between a 55 and a 60? Figure out the percent first, and then get the actual number. in between a 55 and a 60, we're looking at 2.35% of 2,000, which means I need to move it to the left by 2.0235 times 2,000. 0.0235 times 2,000. Expecting a small number, 47. 47 students scored between a 55 and a 60. Not very many. So there is our first one on this homework. This is what is due for tomorrow.